Hi, this is a part 2 of the second derivative test videos, and just a quick refresher. By now you should have some understanding of what the second derivative test is. First we find the second derivative, then we're going to find out where the second derivative is 0 or undefined. We're going to plot those points from that step on the number line and determine the signs, and we're going to see what's going on. So if the second derivative is going to be positive on a certain interval, then the function is concave up. If the second derivative is negative on an interval, then the function is going to be concave down. If the second derivative is going to equal 0 on a particular interval, it's not going to be concave up or concave down. And if there is a sign change of the second derivative at a particular point, then you will have a point of inflection at that point. And do not assume that every point where the second derivative is 0 will be a point of inflection. The function's second derivative must have a sign change. Alright, we have this function f of x equals ln of x squared plus 1. So we want to find where it's concave up or down. We need points of inflection. So first thing, of course, is to find the first derivative, which is going to be 1 over x squared plus 1 times 2x, which is going to be 2x over x squared plus 1. So the second derivative will be 2 times x squared plus 1 minus 2x times 2x divided by x squared plus 1 squared. I don't want to go through all the algebra here. Well, actually I can do a little bit. 2x squared plus 2 minus 4x squared over x squared plus 1 squared. We are going to end up with 2 times 1 minus x times 1 plus x once it's all simplified and factored over x squared plus 1 squared. We're going to set it equal to 0. So the denominator will never be 0, we just have to worry about the numerator. We have 2 points. It's going to be when x equals 1 and negative 1. So we're going to plot those points. Negative 1, 1. This is f double prime of x. And the signs will be negative here, positive here, and negative here. So since the second derivative is negative, here will be concave down, negative here, concave up. These 2 points will be points of inflection. So we're going to write that concave up on negative infinity to negative 1 and 1 to infinity. Oh, I'm sorry, that's down. Concave down, infinity, concave up on concave up will be on negative 1 to 1, and it's going to have points of inflection at x equals 1 and negative 1. So 2 points of inflection is because the second derivative changes sign at those points. Okay. Same question for this function. So we are going to have to find the first derivative, which is going to be 1/3 times x minus 1 to the power of negative 2/3. And the second derivative, f double prime of x, is going to be negative 2/9 times x minus 1 to the power of negative 5/3. Which can be written as negative 2 over 9 times x minus 1 to the power of 5/3 positive. You set it equal to 0. It's never going to equal 0 because this derivative does not have any values that will do that. But we also have to remember that whatever number makes the denominator equal 0 will be where it's undefined, and it's a candidate too. So when we are going to draw our number line, and we're going to put 1 here, we are going to figure out how the signs are going to go. It's going to be plus here, and it's going to be minus here. So the function is concave up, where on the interval from negative infinity to 1, concave down on 1 to infinity. Now here's the thing, if you look at this, the first derivative and the second derivative are not defined at 1. However, the function itself is defined at 1, and that point here that we just found is going to be a point of inflection. So we have a point of inflection at x equals 1. Alright. Moving to the next example. So I have this function, x plus 2 to the power of 2/3. Okay. Well, let's go ahead and take the derivatives first. So f prime of x is going to be 2/3 x minus x plus 2 to the power of negative 1/3. F double prime of x will be negative 2/9 x plus 2 to the power of negative 4/3, which is going to be negative 2 over 9 x plus 2 to the power of 4/3. Okay, and we set it equal to 0. Similar situation as with the previous example, there are no points like that, but we have to consider negative 2 as our point. We're going to make a number line. We're going to put negative 2 here, f double prime of x. The signs will be minus minus. Okay, so here's what's going to happen with this function. You are not first of all, you don't see a sign change, which means you do not have a point of inflection. The function itself, even though the second derivative and the first derivative too are not defined at negative 2, the function itself is defined at negative 2, but there is no sign change, so the function is going to be concave down on these two intervals from negative infinity to negative 2, and also from negative 2 to infinity, concave up, not applicable, and no points of inflection. Okay, again, just because the second derivative is 0 or undefined does not mean that you are automatically going to have a point of inflection at that point. Right. Next example, there's a function, same questions. So we find f prime of x, which is going to be 2x times e to the x minus x squared e to the x divided by e to the x squared, which is going to give us 2x minus x squared divided by e to the x, because we will be able to divide the numerator and the denominator by e to the x. So f double prime of x is going to be 2 minus 2x times e to the x minus 2x minus x squared times e to the x all over e to the x squared. Again, e to the x can be divided, and this whole thing is going to simplify to x squared minus 4x plus 2 divided by e to the x, and we're going to set it equal to 0. So we have this function here, the quadratic function that can possibly have zeros. The denominator is not going to be 0 for any values, and e to the x is always going to remain positive. So the sign of this expression here, which is our second derivative, is going to be determined by the sign of this quadratic expression. So x squared minus 4x plus 2 equals 0. If you solve it, you are going to get, I don't want to go through this, you're going to get 2 plus or minus square root of 2. So these are 2 points that we're going to need to plot on the number line. 2 minus square root of 2, 2 plus square root of 2. This is f double prime of x. the signs will be plus, minus, plus, which means the function is concave up, concave down, concave up, but that makes these 2 points points of inflection. So it's concave down on negative 2, I'm sorry, there's no negative, let me rewrite that. So it's going to be on 2 minus square root of 2 to 2 plus square root of 2. It's going to be concave up on an interval from negative infinity to 2 minus square root of 2, and also from 2 plus 2 square root of 2 to infinity. And we are going to have points of inflection at these 2 points. X equals 2 minus square root of 2 and x equals 2 plus square root of 2. Okay. Moving on. We have a couple more examples left. Find where this function is concave up or concave down. So f prime of x is cosine x plus x. F double prime of x is going to be negative sine x plus 1. And you set it equal to 0. Okay. And this function is going to be, what are we going to have here? We're going to have solutions at every point. So this is going to have solution at pi over 2 plus 2 pi n. Right? So what do we know about this expression? Negative sine x plus 1. Sine x is going to oscillate between negative 1 and 1. When you add, so negative sine x, well, is going to oscillate between that. So in this case, we can say that this is always going to be greater than or equal to 0. So you have no concavity change. It's going to remain below the, this function is not going to go above the x-axis. Actually, it's going to stay below. It's going to be concave up everywhere except where equals 0. Okay, and it has no points of inflection. Okay, and one last one. Where is this function going to be concave up or down? Any points of inflection. So we'll start with f prime of x, which is going to be e to the x plus x e to the x, which we can rewrite as e to the x times 1 plus x. F double prime of x is going to be e to the x times 1 plus x plus e to the x, which is going to be e to the x times 2 plus x. We set it equal to 0. That's going to give us 1 point, negative 2, our number line. F double prime of x, negative 2. The signs will be minus here and plus here. So it's pretty easy. It's going to be concave down on the interval from negative infinity to negative 2. It's going to be concave up on an interval from negative 2 to infinity, and we will have a point of inflection because the second derivative changes sign here. At x equals negative 2. Okay, I hope this was helpful.